Okay, in this video we are doing Calc BC Problem Set number 1. A link to the problems and the playlists are in the description below. Let's get started. We want to evaluate the integral of x cubed minus 3x plus 1 over x squared plus 4 dx. Alright, so we need to have a proper fraction, so if the degree of the numerator is higher than the denominator, we're going to do long division. So I'm going to set that up. It looks like this. I put in placeholders, so x squared plus 0x plus 4, and then I put in another 0x squared, just so everything kind of like fits where it should. I look at this and I think I need to multiply x squared by x to get up to x cubed. So we're going to put an x here. We're going to multiply x squared plus 0x plus 4 times x. We're going to put it down here and we're subtracting. So we end up with negative 7x, and then we bring down the 1. Now this is a lower degree than x squared plus 4, so we're actually done with our division. So what we can do is we can rewrite our integral. I'm just going to call this thing I. And so we will have I is actually the integral of x plus negative 7x plus 1 over 4 plus x squared. Now I have to decide what to do with this. Well, I'm going to break that up, the negative 7x plus 1 over 4 plus x squared. I think I'm going to get an arctan and a natural log. That happens kind of frequently when you do these problems. So let's rewrite this thing. So we just have x. We have minus 7x over x squared plus 4. That's going to be a natural log, I think. And then 1 over 4 plus x squared, I think that's going to be an arctan. So let's actually do some integrating. So the integral of x is 1/2 x squared. For the second part here, I'm going to factor out the 7 and then think to myself, so x squared plus 4, the derivative of x squared is 2x, so there should be a 2 and a 1/2. So I'm going to end up with the negative 7 that I factored out, a 1/2, that's negative 7/2, and then a natural log of the absolute value of x squared plus 4. Technically, x squared plus 4, well, not technically, actually, x squared plus 4 is always positive, so I don't actually need absolute value on that. But when I integrate and get natural log, I always throw in the absolute value because you got to have it. We need to rearrange this, this third integral, I guess, a little bit. I'm going to divide everything I see by 4. So I'm going to have the integral of 1/4, 1, and then it's x squared over 4, which I'm going to make x over 2, and then quantity squared, because I think this is arctan. So for that to be arctan, I'm going to factor out the 1/4. I have 1 over 1 plus, it should be u squared. So u is x over 2, which means that du is 1/2 dx. There should be a 1/2 in the numerator. So I'm going to put a 1/2 and then a 2 on the outside. 2 times 1/4 is 1/2. So I'll get 1/2 the integral of du over 1 plus u squared. So I have 1/2 arctan of u, or 1/2 arctan of x over 2. I have a lot of videos of how I do this type of integration. Highly recommended if you're not sure what I'm doing. Overall, I think our answer is going to be these things. I'm going to drop the absolute value here, but you could certainly leave it. It wouldn't hurt anything. And then here is 1/2, and then arctan of x over 2. And then we'll have plus c. All right, let's look at the next one. So this one is going to be really similar looking, except this is a proper fraction. I see a quadratic in the denominator, so I kind of immediately think that, so this is really how I think of this. I immediately think this is probably completing the square, so I'm going to try to complete the square. X squared plus 14x. Half of 14 is 7. Square of that is 49, so I'd do plus 49 minus 49, and then plus 45. The issue here is that when I finish this off, I get the quantity x plus 7 squared and then minus 4. That's not what arctan looks like. It would have to be plus 4. So this is actually not arctan. So now I go back and I think, well, what else do we run into in Calc BC? We definitely run into partial fractions. So maybe what I should do is factor the denominator. So I factor it 1 over x plus 9 times x plus 5. I'm going to do partial fractions. So it's a over x plus 9 plus b over x plus 5 equals 1 over x plus 9 times x plus 5. I'm going to do the cover-up method here. So first you start off, you say let x equal negative 9. We're going to be solving for a. We go to the right-hand side, we cover up x plus 9 and substitute the negative 9. So cover x plus 9, it's not there anymore. We get 1 over negative 9 plus 5, so we get negative 1/4. A is negative 1/4. Do the same thing for b. So we're going to say let x equal negative 5. That'll give us that b is, we're covering up the x plus 5. Plug in negative 5, you get 1 over 4. b is 1/4. So our integral becomes the integral of -1/4 over x plus 9 plus 1/4 over x plus 5. And then those are both just natural logs. So -1/4 natural log absolute value of x plus 9 plus 1/4 natural log absolute value of x plus 5, and then plus c. Don't forget plus c. All right, let's look at the third problem here. So this is a calculator problem. So what I'm going to do is actually show you what I did on the calculator. I don't know if I'm going to be talking through it or not. Debatable. So I'm going to go to the calculator, do a bunch of stuff, and I'm going to come back and handwrite some stuff. We are going to have to graph this thing. So graph, and I'm going to graph arcsine. So you can use the trig button and just go to arcsine of x. And then I'm going to hit tab, and I'm going to graph 1 minus x. Enter. So our region is this tiny little thing there. So I'm going to zoom in. Menu, option 4, and zoom in. Click, click. I'm going to click one more time. Okay, press escape to get out of that tool. And now we need to find the intersection of these two things, right? Because I want to find the area of this region. So I'm going to do menu, 8, 1, 4 for intersection. Click, click. I can see my intersection point. So now we have two options. The first one is I can actually just use menu, option 6, and then bounded area, which is option 8. It's giving me this warning. I don't know. It's never really been a problem. Not entirely sure what would happen there. I'm not going to change it. You can just type the lower bound. The lower bound is 0 because you're going from the y-axis over to this intersection point. So I'm going to press enter. And then I will just drag until it kind of like jumps to the point. So I'm going to click here. And you can see 0.2473 or whatever you want to write. Okay, so that's one option. A second option is, and I actually like this option better because for some reason I don't trust bounded area. It's never been wrong, but you could see that warning that it gave. I'm going to click here. So I arrow over this. I'm going to press Control Menu. So it's not going to happen on the emulator on the side. I don't know why that doesn't work, but Control Menu and then Store, option 5. And I'm just going to store this as B. And now what I'll do, let me just, F2 is on top and F1 is on the bottom. I'm going to insert doc 4 and I want to insert a calculator page. And I'm going to do shift plus for the integral. And we want to go from 0 to that value that we stored as B. And then we said F2 is on top, so I'm using the var key a lot. Minus var key again, F1 of x, press tab, x, press enter. We get the same thing. So that's our answer. I'm going to go back and handwrite some stuff. So on the calculator, we found a value. I'm going to call it B. I'll say let B equal 0.489027. So I like to write as many decimals as the calculator shows and then actually use them. Technically for the Calc BC exam, you only need 3 decimals, but you need to use the stored value on your calculator. So you should really solve it the way I did on the calculator, would be my advice. Then we're doing the integral from 0 to b of the top curve minus the bottom curve. So the top is 1 minus x, the bottom is arcsine of x and dx. And then our calculator figured out that the answer is approximately 0.247. So good calculator problem. Make sure you know all of those calculator skills and how to do the problem. All right, let's look at the next one. We want to find the volume when the region R bounded by f of x equals 2x squared minus 3. That's a quadratic that opens up. And g of x equals 2x plus 1. That's a line. So I'm thinking immediately the quadratic opens up. There's a line. The line must be on top of the quadratic for this to be a region. Is going to be revolved about the line y equals 8. We're going to set up by hand and then evaluate on the calculator. All right, so I need to know where these things intersect so that I can know the bounds of my integral. So that's going to involve just setting them equal to each other and move everything to one side. I'm going to divide through by 2 because, I don't know, there's a common 2 and I don't want to deal with it. Factor this thing into x minus 2, x plus 1 equals 0. So we know the bounds now are 2 and -1. Okay, we need to figure out how to like set up this thing. I mean, it says set up by hand, evaluate on your calculator. On the AP exam, you'll see a lot of multiple choice questions in particular that are like, which of the following expressions gives the volume? And then you're just gonna like choose from multiple choice options. So sometimes you don't actually have to evaluate them. What I do is I try to sketch things. So I think f of x is a quadratic that opens up. G of x has to be above it. We know they intersect at -1 and 2. In this case, like, if you choose any value between -1 and 2, like 0, f of 0 is -3, g of 0 is 1, y equals 8 is above the region. That's important. You do need to know that. Okay, so there's y equals 8. Now what we're going to do is we're going to start at the curve that is farthest from the axis, which in this case is f, and just go until you hit the axis. So that's our big R. So big R is going to be 8 minus f of x, right? Top takeaway bottom gives you the big R. Then we need little r, so we do the curve closest to the axis, and then that's going to give us 8 minus g of x. So little r is 8 minus g of x. We're doing pi, the integral from -1 to 2, and then it's just big R squared, so 8 minus f of x squared, minus little r squared, which is 8 minus g of x squared, and then dx. Then we go to the calculator, we use it, I got 702 pi over 5, or approximately 441.0796. I went to 4 decimals there because I really hate rounding that number to 0.080. I don't know, it just bothers me. You could round it, you could not round it, it doesn't make a difference. All right, that's the first problem set of the year. I hope this was helpful, and good luck.